Hello everyone, I'm Xiaogan. Okay, basically we've covered most of the fundamentals of multiplayer online games. Next, let's go through the document again to see if there's anything we missed. We won't cover some advanced topics like the sync table, such as Quack for Graph, because these have only been around for a short time. That is, if you want to use them, you may need to study them in depth on your own. We'll just go through most of it quickly, and for some debugging topics we didn't cover, you can look into them yourselves, because they are relatively simple. We mainly want to talk about the JS in the last chapter. So here, for these missed parts, we'll go through them. So you have a general idea, then you can practice and learn on your own. When you work on your own projects, you can verify and learn step by step, because the course hours for this tutorial are actually limited. That's all for everyone. I've covered everything, because there really is too much content here. As for this case, it's definitely something that will explode when throwing a ball. It's a ranged thing. First of all, here, it introduces what this content is supposed to do. First, it needs to replicate when the actor starts. Then it uses our character to help us write the movement component functionality. At the same time, we synchronize the variables. We enabled property synchronization for the variables. Then we can monitor such a change in property synchronization. Then we wrote it in C++. Then go check an actor's character. And this place is a setting for dedicated server. And network overview stuff. We've already seen it, so there's nothing much to say. And for this basic setup, first, you open a third-person demo. Then make sure that we can spawn such an actor. Because this movement component has actually already this replication for us. If you want to extend the movement component, then you need to do that yourself. Take a look at it. Because the movement component is particularly complex, usually it's for those big companies. You need to modify it. It usually gets modified because it itself, the consumption of this movement component is too high, and there are some things in it that won't be replicated. As for this component, we usually call it Cosme. That is the drawing component. There are also some skeletal mesh animation blueprints. Because it doesn't need much replication, they directly go to read a variable from that character. After reading the variable, the animation blueprint directly reads the local client count, updates the variables on the actors, using this method to present such a performance effect. And at the same time, our gameplay framework, our game mode, how to generate actors, how to handle player control, how to restart the game. This series is all the basics of Blueprint. We won't go into depth on it. And at this point, it is actually already a normal multiplayer game. We start adding features. First, we added a maximum health value like this. And as for this health value, it is set to edit default only here, because it is the maximum health value. So we don't need to change it on the instance, because all its values are the maximum. So we generally use edit default only. And this is the current health value. If it reaches 0, we will die. And here, every time the health value is changed, there will be a callback method. This method must be a function. And here, so this is a constraint on the health value. This is a corresponding explanation for it, and this is protected. Because it is externally protected, only we can modify it ourselves. Then, regarding this part, because you are dealing with these variables, they need to be synchronized over the network. So you need to include the network synchronization file. Then you must register this variable before it can work, unlike Blueprint. Because Blueprint has already done it for us. So first, after including the network variables, then in this place, first in the constructor function, you perform a simple initialization on it. After the initialization is complete, he added a new override method here. This place will define the life cycle of these variables. And here we need to add a drop lifetime macro to register the thing we want to synchronize over the network. This idea is very common through registration. After the registration is complete, remember to always call super. If you don't call super, problems will occur. This is lifetime has many implementations. That is how exactly this variable is synchronized. When to synchronize, then you can customize it or use the engine's default settings. This method uses the default implementation, and this is the update method. So obviously, in this update method, it will determine it's the client's functionality. On the client, we only need to print the log. Of course, when dead, it also falls off. The log has been printed, already dead. Then if it's a server-specific feature, actually here, it also just prints how much health is left. Yes, and this place doesn't distinguish. That is, everything can be. If you have some other logic, then here You can write it in this place. If you want to modify UMG, you're about to write this chunk. And if it's a server, for example, if the server needs to do damage statistics, you can write it here. If there are some other things, you can add them after this. This way, every time the health value is modified, it will execute. We can demonstrate this in later cases. And note, this method, this onHealth update, it is not automatically called. It needs to be called manually. Call it on the server immediately after modification, and then on the client, you use the call to respond. Then on the client, it is called this location. Then this location actually is where the client responds to this call. Then here, when the player responds to damage, actually, the call at this location, the timing of this will only be known after testing. We will only know after writing it, because this thing may differ from blueprint behavior. Possibly not the same. Sometimes this function, you might, when dealing damage, manually call it, which is possible. Then this place is where the player responds to damage. Add some functions here. Just some get sound. Head function in this place. He uses this TakeDamage. TakeDamage is an event for receiving damage. So these things here should be a fixed pattern. Should be an override. You see, it is an override. Such a method, and here he uses this const modifier. That is actually, it is a method that does not allow modification, only allows access. Then this is a set method, which can modify the current health value. Then you are only allowed to modify it on the server. After the modification is complete, it manually, indeed, manually called it. You will find that when we use blueprint, we did not manually call it. We direct set it. Therefore, blueprints and C++ here have significant differences in RPC and data synchronization. You must not write blueprint and then take it for granted when using C++. Just took it for granted and used C++. You still need to argue about it. So on the server, this method is called manually, and then replication happens here. After replication is complete, it will jump to this place. Jump here. Okay, let's look further down, and then this place, it provides this set in this way. It can be called anywhere, but it is clearly specified. It only takes effect on the server, and then here a health value with a limit on the maximum and minimum values, right? There shouldn't be any problem either. Then this side prompts you that this kind of getter-setter function is great. Why is it great? Because this is a game variable for sensitive processes. If you don't use this kind of getter-setter function, it's equivalent to when you modify this value. You don't have a unified entry point. Then it will cause 10 or 20 places, all to be modifying it. And the modification logic in those 10 or 20 places is not the same. But if all these places are modified through this one function, then it's very convenient when you debug and modify, because this is their unified entry point. Then here, when it receives damage, then it's TakeDamage. It is an overridden method. Then in here, it takes this damage value and modifies it, does an addition or subtraction to the health value, then just returns it. Because there might be some armor calculation stuff here, this is our Unreal Engine custom Badone damage system, I think. Then it explains it to you here. Just this TakeDamage. Why didn't you write a still damage yourself instead of using the engine's bidding one? Because the engine provides you with this damage, the whole process of kit damage and receiving damage. So by embedding into this process, you can easily modify your own attributes, integrate all these things together. After you integrate them together, it becomes very convenient when maintaining code and its implementation. It doesn't use the server client, RPC and such. It's essentially a very streamlined implementation, equivalent to a minimal implementation. So it's very convenient. But for now, it only depends on this critical, such a replicated and effective modification model. This part is a bit convoluted. But when we write it, you will understand. Okay, now let's look at it. Use replication to create a projectile. So here, it creates an actor, a C++ class code, and then here, it defines this object. First, it has a static mesh, it has a collision box, has a basic model, has a projectile component, has a particle system, also has a damage class. Then this part is a specific, the damage value. This part uses a forward declaration to avoid including header files included in the source file. So there is no need in the header file to include the header file. Then this part is a brief explanation. It uses these components respectively, what they are used for. Then This place, this projectile movement component, this place needs to set this actor. To replicate, the projectile movement component will handle replication automatically. Let me emphasize this point. This place is to include the header file, and this place is to enable its replication function. Then, after the replication function is enabled, when it spawns, it will notify all clients that something will be spawned. This place is to create these components one by one. Obviously, this component, we have already created it, and this component is from the starter pack. He went over there to find one. Then, if it has been found here, if it is successfully found, actually, we can specify it through blueprint here. If he likes to write it this way, there's no problem with us writing it this way either. Then, find this thing. After finding this resource class, just set it up. Then, next, this is just finding this example. Nothing much to say. We've done it many times before. This part is to set the movement component. Use some of its initialization parameters to do things. Because this component will also be replicated, and here it uses the default damage type because you can define some fire type. Ice type damage. This is some knowledge of Blueprint. If you have done game development with Blueprint, you should be able to use its damage thing. But from now on, we will use GS. Just have a basic understanding of this part. So we just use the basic damage type. Now that we have such an object, obviously, we need to do some object lifecycle management here. This is overriding the destroy method. So when it is called to be destroyed, we can spawn a particle effect. That's pretty good. And because this particle system of ours, we generally do not replicate it. The text story will replicate, so we can just call it directly here because it can be called on all player clients. So this thing is attached to a story that will be called. To implement it, and here it has added a collision. You can see this is clearly for collision, and here it has made this place is a collision like this. So when it impacts, that is the collision point, the collision location, and then this is when the collision happens. After it generates the collision, we use something like kiss me, found in the static function library. We use something like apply point damage. Apply this damage. After applying it, we can destroy ourselves, but this whole thing, we definitely need to execute it on the server. So a smarter way to write it is to only bind it on the server, meaning only on the server does this binding functionality exist. This is a point that requires great care. And then finally, we will launch this projectile. First, let's prepare a left mouse button to trigger it. Then trigger it, and here we are not using the enhanced input system. We are directly using this key mapping. And here, when we trigger it, we need to bind this start fire, and handle fire. These methods here make this place designable, a hold and press. There might be a hold and press. Such a design, we can take a look. And then this place, we definitely need to execute it on the server shopper. So this handle file needs to be in RPC, right? And this place is called locally from the client. This place is for protection because you might keep clicking, it keeps sending. Then the frequency of this design is too high, right? So here it creates a timer. So how does it do that? First of all, when initiating, we first find our projectile class. Then we initialize some parameters. When we press the fire button, we cannot be in the firing state. So here we create a timer. That is, every time we fire, we have a 0.5 second reload time. That's the idea. So here we create a timer. After we create the timer, because we need to wait 0.5 seconds, we reset this boolean so it can fire again. And in the actual firing part, it will go into this RPC. So this RPC is because we need to add a rotation in C++. This kind of speed testing writing. Now it has jumped to the server, spawn this projectile on the server. Then this projectile will fly on its own, and this timer will reset this boolean after 0.5 seconds. That's roughly the idea. Okay, and then after using text here, it describes it again. It means it doesn't want you to keep firing. So a timer was used to give it protection. Yes, then here, within this input, bind this operation. Then finally, it can be tested. During testing, some selections were made here. He changed the mode to display and lesson server mode. Then in these places, you can successfully see this. Then, when it can fire projectiles, it can display explosion particles. Then you keep firing, and after its health is depleted, it will die and play a death animation, etc. Then here you can introduce how to extend it, and at the very end, the entire code. Such a thing can provide you with a verification. Okay, in the next lesson, we will guide everyone to write it step by step to reinforce it for everyone. Because we have already explained to you earlier, explained property synchronization and RPC, so this case should be relatively simple. However, the special point is that it is written in C++. Okay, we will stop here for this lesson.